All right, our webinar is divided in two modules. The first module is a general comparison of the different weather stations that we have. So it's a comparison and overview. The second part of the first module will be about the correct mounting of the KNX weather stations. The second module will focus solely on the Suntracer KNX Pro. So we will discuss the special features that the Suntracer KNX Pro has. We will discuss how to set threshold value for wind direction and wind alarm. Next up, we will discuss the settings of the facade automation. So about the first module. After the first module, you will be able to select the appropriate Elsner weather station and to distinguish a good from a bad installation. Let's get into it. So let's start with the comparison and overview. All right. On the left photo, you can see the largest version of our KNX weather station, the Suntracer Pro, which will be also the main focus of today's webinar. This product has facade automation for up to 12 facades, so for rather big building projects. The special feature of the weather station is that it can detect the wind direction, which is the only weather station we have that can do that. Next up, we have the Suntracer SL series. We offer these in the various versions, for example, the Suntracer SL, Suntracer SL Lite, and Suntracer SL Basic. We will take a closer look at the differences between the models on the next page. Next up, we have the P04 KNX weather station. This is the smallest version of the KNX weather stations. The device has no facade automation or logic functions included. With this device, only the measured values can be sent on the bus, for example, to a building management system. Next up is the newest edition of our KNX weather station family. So on the right side, you can see the Wind Dancer KNX GPS. The device has very similar functions to the Suntracer SL Lite. The main difference is that the wind measurement is done in a different way. So you can either do it with a mechanical wind measurement, like we did it with the Wind Dancer, or you can do it with electronical wind measurement, like in the other versions. So the following table shows the weather stations in a comparative overview. The table is very helpful in choosing the right weather station for your specific project. So let's dive deep into this chart a little bit. So in the table under the point automation, you can see how many facades the weather station can control. In the first 4 rows, you can see the sensors and the systems such as air pressure, air humidity, or wind direction. So the table can be found on our website. If you can't find the table and you need to find it, feel free to send me a message. I'll be more than happy to send you the link. Okay, the next topic is the mounting of the weather stations. It seems like one of the easiest tasks when starting to work with the KNX weather station, but actually, if I look into our service cases, it seems like one of the most complicated tasks. So in the following chapter, we will deal with the installation of weather stations. Okay, first up, we will start with the mounting type of SL. All weather stations with this housing and the shape of the Suntracer SL, as seen on the photo on the right, are mounted identically. So the weather station can be attached directly to a pole on the roof with a clamp or on the wall. So here it must be noted that depending on the wind direction, the weather station is located to the lee of the facade. Therefore, the installation on the facade only makes sense if shading sits on the same facade. Furthermore, the weather station can be mounted with the help of a boom. You can see that here on the picture. This helps to separate the weather station a little bit from the building, so it's very much exposed to everything that the weather station should actually measure. So one of the most common mistakes is actually that you try to sort of hide the weather station and install it under the roof so it doesn't get wet. But that's not the right approach, because obviously for the weather station, to measure as exact as possible, the exposure needs to be as high as possible. So also 60 centimeters below the wind sensor needs to be free so the wind can actually reach the weather station. Next up, we will discuss the mounting of the Suntracer KNX Pro. The Suntracer KNX Pro weather station must be mounted on a mast on the building due to the wind direction measurement. So here you can see the Suntracer on a mast. The mast extension as well as suitable mounting material is included in the scope of delivery, so you do not need to purchase this extra. Here you can see the assembly with the mast as an extension. The weather station must be oriented so that the base of the device faces north and the ring faces south, as displayed here. Also, here in this picture, I added the north and the south orientation. All right, we are already at the point of our first practical exercise. So here's the question. Which of the three weather station is installed correctly? I give you a couple seconds to look at the picture and then we will start the survey. All right, now we can start with the practical exercise. All right, it seems like no more answers are coming through. Let's discuss the results. So 42% of the participants voted for number 1, 33% voted for number 2, and only 25 voted for number 3. So let's see what the correct answer is. So the answer is actually number 3, and only 25% got it right. Let's shift back to the 3 possibilities and discuss what went wrong in those installations. So in picture 1, you can see there is not enough space below the wind sensor, so that means the wind measurement won't work correctly. In the second picture, you can see the weather station is sort of hidden under the roof for whatever reason, and the orientation is not in the right angle of the weather station. So number 1 and 2 is not installed correctly. On the other hand, number 3, it has enough space below the weather station so the wind measurement can work fine. Also, due to the boom, the weather station is a little bit separated from the facade and the exposure is high enough to measure correctly. Okay, next up. Let's end the first module with a quick summary. If you have any questions at this point, feel free to ask them in the chat and we can take some time to answer them now. So yes, we're at the end of our first module, and now we can distinguish different weather stations and we know how to mount the weather stations correctly. I'll wait a couple seconds in case there are any questions and then we will continue. All right, no questions so far, so I'm pretty confident that we explained it well enough. If you have any other questions, feel free to post them at any time. Let's continue. So next up, in the second module, we discuss the specialities and the functionalities of the Suntracer KNX Pro. After this module, we will know the special features of the KNX weather station, the possibilities of limit setting values for wind direction and wind alarm, and the settings of the facade automation. I just saw that a question came in, so give me 1 second to read it. So there was an interesting question. So the question was, do I need to protect the weather station from hailstorm? So we produce our weather stations with a high rating. It's IP45, so there is no reason to try to save it from hailstorm. They can handle it. Of course, if there will be a hailstorm of the size of tennis balls, then even our weather station will have a problem. But this is so seldom that a regular hailstorm won't cause any problem. So do not try to protect the weather station. Put it as exposed as possible to have the most accurate measurement. That is the main goal of using a weather station. There have been another question regarding the automation topics, so we will discuss this later on in the webinar. So I'll continue and I'm sure your question will be answered. This is the question about the light value during the day and the light value during the night. We'll discuss this later on. Let's continue. Okay, so first of all, let's check out the sensors that the Suntracer KNX Pro has. Here you can see a little graphic and a visualization, but let's go into that in more detail. First of all, of course, we have the temperature measurement, which is very important as a value that you should always send to your KNX bus so you know how warm or how cold it is outside. This is important for realizing, for example, automated heating or venting functionalities. Next up, we have the wind speed and the wind direction. With Suntracer Pro, it's quite interesting how we do the measurement because we have 4 ultrasonic sensors. You can see them in the middle of basically of the ring, and this is how we do the measurement. So next up, the brightness sensors are very important for automatic shading control. So we do have 5 sensors in total on top of the weather station. Next up, the precipitation. So this is if it's raining or if it's not raining. Next up, we also have a humidity sensor increased. Also, air pressure for sort of predictive weather services. Next up, we have the GPS location. So your entire KNX installation, every room controller can get the time and the location via the GPS reception. Also important for the shading automation is the sun position calculation, which is done via the GPS reception as well. All right, so next up to the functionalities. The Suntracer Pro is our biggest weather station, so you can realize automatic function for up to 12 facades. How to count facades, we will discuss later on with several examples. So the display of the sense temperature can be done via the Suntracer. Also, the wind measurement with the wear-free with ultrasound can be realized with the Suntracer KNX Pro. The output of the wind direction can be given in degrees or in text form. The output of air pressure can be displayed in your automation visualization in hectopascal or in text form. So usually if you program KNX devices, you need to press a manual switch, not with the KNX Suntracer Pro. So we send a small magnet and you need to put a magnet on a specific spot on the Suntracer in order to launch the programming mode. So in this chapter, we have learned more about the special features and the sensor technology of the Suntracer Pro. Next up, we will learn what we can actually do with this functionality and how it helps us to realize automatic shading. At this point, I'll make another couple seconds break to give you the chance to ask some more questions. After that, we will go more into detail about how to setting the wind direction and the wind threshold values. All right, let's continue. So let's get a little bit more into the technical areas of the system integration when it comes to a KNX weather station. So the setting of the wind direction threshold values is not integrated in the facade and must therefore be parameterized separately. If the wind direction is to be integrated into the facade automation, this is done via an input object. This input object is the safety, for example. Here the wind direction threshold value is applied and the output object is a 1-bit object and it is linked to the input object safety. Don't worry, we'll have a look at the ETS application in a bit to discuss this in more detail. Okay, so next up, the next couple slides will be actually extracts from the ETS application of the Suntracer KNX Pro. I always put the path of the ETS on the top so you know how to find those parameters. Okay, let's get into the parameter settings. The range specification can be specified via the parameters. You have a fixed value in the application. or this can be done via a communication object, for example, via a visualization. In the next step, a hysteresis need to be set. The hysteresis is basically the switching point between range exceeded and no longer exceeded. We will explain this in a little bit more detail, and also we have a short graphic. If you do not know what the hysteresis is, it will be explained in the next couple of minutes. So in the next setting area, we can set a delay time from 0 to 1 and from 1 to 0. So for example, from 0 to 1 means 2 seconds, and from 1 to 0 means 5 minutes. This causes that the wind direction must be fulfilled for 2 seconds so that a 1 is sent to the bus. If the wind direction is no longer fulfilled for 5 minutes, a 0 is sent to the bus again. So for example, to release the shading. In addition, there's a setting how the switching output should be sent. So for example, on change or on change end cyclically, including an adjustable transmission cycle. The output of the threshold value can be deactivated or blocked via a blocking object if that is desired. Now we will discuss the setting of the wind threshold values. So the setting of the wind force depends on the curtain used in the design or positioning of the object. The maximum wind value that your blinds can withstand must be therefore requested from the shading manufacturer and not for us. Usually you can also find this in the technical data sheet of the blind provider. Okay, we have already discussed the first point, for example, the threshold values received via the communication object and when the blinds should be retained in the case of the wind direction threshold value. The wind threshold value can be specified via the parameters, can be a fixed value in the application, or once again via the communication object. In the next step, a hysteresis must be set. The hysteresis can be set in percent or as an absolute value. So here a quick explanation. The hysteresis is the switching threshold between the wind value exceeded and undershot. So here in our example, we have set 4 meters per second as a wind threshold value. So if the wind value of 4 meters per second is exceeded, the alarm 1 is sent to the bus. If the wind value falls below 4 meter or 2 meter per second hysteresis, the alarm is deactivated and a 0 is sent to the bus. This is a very important functionality because, for example, if you have a wind alarm and the wind is very strong and you know, for example, that your blind manufacturer said our blinds can only withstand 4 meters per second, it's very important that the blinds retract if there are some very strong winds. But after a couple minutes, if those strong winds are not there anymore, then you want the automatic functionality to start again. So this is basically a saving mechanism, so no damage is caused due to too much wind. More about this later and more in the next graphic. So in addition to that, we can also define how the switching output is to be sent. It can be sent cyclically or on change or on both, as well as the cycle time can be set. In the first step, we can specify whether to enable the lock with the value 1 or 0. In the second step, the value of the lock is defined before a communication object is sent. That means whether the lock is active or inactive after reprogramming. In the last setting, we can specify if we want to send a certain value when locking. For example, lock active, wind alarm. Okay, here we try to visualize the hysteresis a little bit. So the actual hysteresis you can see on the dotted line. It's the below yellow line. The top yellow line is the set threshold value and the blue line is the course of the wind speed. So you see on the y-axis, you can see the meters per second, and on the x-axis, you see the time that has passed. So let's look into this a little bit. In the beginning, you see that the wind is below the hysteresis, so no alarm should be triggered. Then it is in the hysteresis, and after a certain while, it exceeds the threshold value. So this means the wind is stronger than our threshold value. That means a wind alarm is triggered and the blinds should be retracted. This is done over a specific course of time. We said 5 minutes, for example. If after 5 minutes the wind is still really strong, the blinds should not be retracted. But if after 5 minutes the wind is slower than the hysteresis, then the automatic functions can start again. This is basically the alarm function and the safety function, so no damage is caused on your facade automation that I mentioned before. Okay, now we will discuss the setting of the wind threshold values in the facade control system. In my example, I used the wind alarm by a threshold value. So since I used the wind value measured by the weather station, I have selected the measured value from the internal sensors. If the individual wind sensors on the building, for example for the facades, can be integrated via a communication object. For this, the setting measured value from internal sensors would be set to no. For this, the measured value of facade 1 wind is activated. The following object would then receive the measured wind value from the external individual sensor of the facade. Here you can see the communication object. A maximum of 12 individual sensors can be integrated. So why do I even need individual sensors? So individual wind sensors are sort of important if you have a high building, because the wind speed will be very much different if you look in the first couple of stories of the building and the highest. So usually on the high stories of the building, the wind will be way stronger than lower. That is how you can monitor the different conditions of the building. For example, the lower portion of the building and the higher portion of the building. On the right window, we can still see the setting of the wind threshold value. Let's move on to the summary. So in the previous chapter, we dealt with wind direction and the threshold values, also wind threshold values, and the very important function of wind alarms. Once again, I'll give you a couple seconds to think about what we just discussed. If you have any questions, now is the time to post them. All right, let's move on. The next part of the second module is the actual facade automation or the facade control. Let's look into the functionality. So I would like to briefly introduce the individual functions of the facade control system. So for example, first of all, we have the timers. So we can realize a time open or a time close. So for example, in my personal home, after 9:30, I want all the blinds to go down. This is also some sort of security function, and it's a very, very simple time functionality. The same can I do on the weekends. I wanted to have open, for example, at 8. During the week, I wanted to open at 7, so a little bit earlier. Next up, we have the night closing, which I explained before as well. We have the heat protection, which is especially useful for the use case we discussed in the beginning, because if we can actually manage to keep the heat outside of the room, we do not use that much AC power, and therefore we can make our building a little bit more sustainable. Next up, we have a pyranometer that we can add externally. Also, we have the rain automatic, which I just simply love as a function. For example, several weeks ago, I got an invoice from our facility management that had to come and clean our blinds. And they do this usually 2 times a year, and it's quite expensive to clean all the blinds. So we realized the rain automatic. So that means that the blinds go into a cleaning position so that it's actually exposed to rain. So the rain sort of washes away all the dust that have been on the blinds in the past. I'm sure without this functionality, our service provider would have need to come several more times. Another functionality is the indoor temperature block. So the automatic sun protection, we would like to deal this more in detail in the next sections. Also, we have the outdoor temperature block that can be realized. So in a separate section with the protection functions of the facade, we will discuss the wind speed, the frost alarm, and the rain alarm. Okay, let's get into it. So many people ask me, okay, see, here you have basically the blueprint of the building. Which weather station should I use? So one indication what weather station is the right one for you is always to count how many facades do I have. Let's start very simple. Here we have one building blueprint with simply 4 corners. So here we have 4 facades that can be controlled. Most buildings have 4 facades and it can be made, yeah, kind of easy to realize the automatic shading functionality. The solar protection of each facade should be therefore controlled separately. Even when buildings are a little bit more complicated or seemingly more complicated, like this U-shaped building, you still only have 4 facades because the orientation won't change. So you basically have the facade 4 twice, the facade 3 times, and the second facade you have twice again. So this is basically how we count the facades and to decide which weather station is the right one for me. Here we have a little bit more complex blueprint of a building. So for buildings with an asymmetrical floor plan, the division of the facade is somewhat different. The facades with non-rectangular orientation, for example, facade 2, 3, and 5, and the setback facade 6 must be controlled separately and can be grouped in with other facades. So this division can be seen on the floor plan shown curved round fronts should be also divided into several facade segments to be controlled separately and reach the highest degree of automation possible. I'll wait a second so you can really have a look at this floor plan, and once again, if you have any questions, feel free to ask them. All right, so the numbers coming in are slowing down a little bit, so I'd like to give you the answer. And 78% of our participants had the right answer. So the solution to the exercise is that this building has 4 facades. If you paid attention before, it's basically the floor plan we've seen before turned around. So yes, everyone that said 4 facades, you were correct. Okay, let's get into the next topic, the alignment of the facades. This alignment can be set in the following paths. So you have the Suntracer KNX Pro, you go into the facades, and you go into the Façade X automation. So for the facade automation, we need to define the alignment of the facade. The facade alignment corresponds to the angle between the north-south axis of the perpendicular to the facade. North thus stands for 0%, for 0 degrees, and the alpha angle is measured here in a clockwise direction. So in the example, the angle here marked in red is rotated by 30 degrees to the north. Thus, the alignment for the facade corresponds to 1 equals 30%. The other angles result from the alpha angle plus 90. You can basically see that here in the figure. This might be a little bit complicated at first, but once you understood it, it's fairly straightforward to program in the ETS application. Let's move on to the inclination of the facade. Here we have another angle that is sort of important to realize a high degree of automation. So if a facade surface is not aligned vertically, which happens quite often, this must be taken into account. So an inclination of the facade to the front is countered as a positive angle. An inclination to the rear, as in the next figure, is basically an inclination, the value 0 is entered. So here the adjustment of the inclination is to be made. Here you can see the section in the ETS application where you can set the inclination of the facade. Let's discuss the sun direction a little bit. So here in this graphic, just as a quick explanation, the 1 symbolizes our building. The green dots mean trees that surround the building, for example, and the yellow line and the sun obviously stands for the course of the sun that the sun takes over the course of the day. So the position of the sun indicates the area of sunlight on the facade. Depending on the surrounding conditions, the area must be adjusted. So the sun range is often already restricted by neighboring buildings or plantings. So here it does not really matter if it's a tree or if it's another building, you will do the same thing. So as can be seen in the following example, the building is already shaded by trees. So the trees are the green dots once again. So due to the rising sun in the east, this natural shading exists and the blinds do not need to be lowered. So basically you only want to lower the shades if it's absolutely necessary, because of course daylight is a beautiful thing in the building and you do not want to have it dark the entire time. So only when the sun moves during the course of the day, like you can see here in the second figure, it does hit the building unhindered. So this is when the shading is actually required. Therefore, the sun area is entered in the following parameter settings. Here are the parameter settings that can be set to realize that. So for this setting, we offer fixed areas, for example, south, east, west, and combinations of that. An individual adjustment of the ranges is also possible. So for this, the angle range is activated. Now, the individual sun ranges can be entered in percent. Here you can set the percentage of the angle range. Next up, we'll discuss the sun height. So in the next point, we consider the height of the sun. Let's take this photo as an example. So the facade is shaded by the projecting roof when the sun is high. Only when the sun is low, approximately below 53 degrees below the roof, the shading is necessary. So here we have the alpha angle that can be set, and you know, okay, the roof will cast a shadow. So in the mornings, for example, the sun is not required. If the sun gets lower, the shading is required. So for example, in this specific setting, it could be, for example, from 0 to 53% shading is required. That can be set here in this section of the ETS application. Do not worry if this is all a little bit fast, as we will record the webinar, so you can rewatch it, pause it, go in the ETS application and put these settings for yourself. Next up, we will discuss the brightness. Earlier, there has been a question about the brightness and how you need to integrate it in the facade automation. Now we'll go into more detail about the brightness sections. So in the following image, the parameter of the brightness are shown. We can select whether we use the internal sensor system or an external sensor system of another transmitter for the threshold value. So basically you can place a lot of brightness sensors around the building. So the threshold value for brightness is, for example, 60 kilolux. For falling below the threshold, a hysteresis in percent can be selected. In addition, there are corresponding delay times for brightness control. For example, extension delay, short retraction delay, and retraction delay. Let's make an example. So if the brightness limit value 60 kilolux is exceeded for 1 minute, the shading extends. So if it's very bright, the shading should extend. So if there's a cloud after the extension and a short delay of the 60 kilolux is interrupted, for example, 10 seconds, the slats can be opened a little bit to let some daylight in the room again. If the threshold value is undershot for 30 minutes, the shading is retracted again. So those threshold values and those delay timers are actually very important to not realize, I would say, a silly automation, because you do not want your slats to move every 10 seconds. So therefore we need those extension delays and also brief delays, so that we have sort of yes, a clean automation that does not move if there's only a very slight change in the external values. Let's move on to the next topic, which is the slat and shadow edge tracking. So in the facade automation, you must select which shading function is desired. There are the following options. So you see here the picture, the sunshade for medium position of the sun. So here we have a medium position of the sun. The sunshade is automatically lowered only so far that the sun does not exceed the maximum permitted penetration depth into the room. When we have a lower sun position, then the slat position should move accordingly. So the sunshade is automatically lowered a little bit more to almost completely, so the sun does not shine too far into the room, but we still do have enough daylight. Okay, I'll wait a little bit so you can actually have a look at the picture, and if there are more questions, feel free to ask them. In the third picture, you see the last example when the sun is very low. Once again, remember you always have the option to ask a question. Also, you can send us an email if you have some more questions. We're more than happy to answer that. We are aware that this is a lot of content to put into a 45-minute webinar, but this is the sort of depth of knowledge that we need in order to make a good shading automation for your next building automation project. Let's move on in the program. Let's discuss the details for slat setting. So first of all, it is required to determine the slat type. You need to know the width and distance of the slats. This is here displayed. So therefore, it does not really matter if you're using horizontal or vertical blinds, because both can be used for the shading of the facades. Both types of shading can be controlled so that no direct sunlight shines into the room. In order for the shades to be controlled correctly, the distance and the depth of the slats must be known and need to be entered into the parameters in the ETS correctly. So this can be measured with a normal measuring tool where you can see the centimeters. So simply have a look at your slats, measure them, and enter them accordingly into the ETS. So the possible angle at slat position 0 depends on the mechanics of the shutter and the actuator. Shades do not fold inward are shown in the two pictures on the left. So in the first picture, we see an angle of 90% with a slat position of 0. In the second picture, we see an angle of 10% with a slat position of 100. So shades that fold inwards exist as well. So here it goes the other way around. So here in this example, 160 degrees is at 100% at slat position. The angles must be measured out. So for example, with a set square or requested from the shading manufacturer to determine values then entered in the parameters. You can see the parameters right below. Next up, we can discuss the slat position for vertical slats. So the possible angle at slat's position 0 depends on the mechanics of the shutter and also on the actuator that is used in the project. Shades that do not fold inward are shown in the two pictures on the left. Shades that fold inwards can be seen in the picture above right. Here the angle is 130 degrees at 0% slat position. This must be measured out, for example with a set square or requested from the shading manufacturer. The determined values are then entered again in the parameters in the ETS. You can see on the below right. Next, we will discuss the facade protection. Earlier, we discussed the wind alarm settings. Remember? The facade automation offers further protective functionalities. Let's start off by the frost alarm. So if the outdoor temperature falls below 2 degrees or up to 5 hours after precipitation, the frost alarm is activated and the shading is retracted. Next up, we have the wind alarm. So the wind alarm is the rain alarm, sorry. In addition to a rain alarm, it can be activated for fabric shades. So this moves the drives to the safety position in the event of rain. So there are also heavily cultural differences. For example, I know that some customers in France, they actually use the rain alarm to extend their shading so they do not get wet if they still want to sit outside. Here in Germany, if we have a fabric that is used for shading automation, we usually retract it because we do not want it to be wet. There are heavily cultural differences, but also this shows the flexibility of a KNX system actually. So both ways can be realized and both ways are obviously valid because in the end it's about the functionality that the user would like to achieve with his or her KNX system. Okay, next up, we'll discuss how the Suntracer includes a status output of the facades via different communication object. So here you can see all the parameters. With the status output object, the status messages of all facades can be viewed. With a plus and minus, you can scroll through the individual facades to query the status outputs. Here, with the blue mark, you can see the different communication objects. The same objects exist as individual status messages for each facade that are called facade 1, channel status output. Once again, if this is a little bit fast for you, do not worry, we will send the presentation and we will also send the recording of the webinar so you can check the ETS application on your own and take this slide as a helping guide to check the parameters in a bit more detail. Okay, let's do our last practical exercise. So here are several options that you can choose from. I will give you a couple seconds to look at the options. Let's start the questions now. All right, thank you very much for attending the last questions. Let's look at the solution. So solution C is correct. We have the rain alarm, the frost alarm, and the wind alarm. 40% of you guys got it right, 60% got it wrong. Okay. Now we can summarize what we have learned in the second module. In the previous chapter, we dealt with the settings of the sunshade automation. For this purpose, we dealt with the definition and the alignment of the facades. Then we got to know shadow edges, slat tracking, and as well as slat distances and angles. At the end of this chapter, we got to know the alarm functions and the status output of the automatic facade control. All right, so if you have any more questions now, we are already at the end of the webinar. So now is your chance to ask. I will stay in the room for a couple minutes more and yeah, just to wait for your questions. Also, if you would like to give me a feedback on the webinar now, that would be highly appreciated because of course we're trying to do the webinars as good as possible. Also, if you have some wishes for future webinars, so what products would you like to see and more suggestions, what we can do better, if it was too long, if it was too short, everything that comes to your mind now after attending the webinar is appreciated. Also, right after the webinar, in a couple of minutes, when I end the webinar, you will receive a feedback form where you can basically click and add some comments how you liked the webinar. Please take your time and answer our surveys because this will help to improve us for future webinars. Of course, we also appreciate nice comments, but to me personally, I'm more a fan of the critiques because that's the way how we can get better. So get anything that is on your mind off your chest in the feedback and help us to get better with our webinars. For now, I thank you very much for attending the webinar. It was a pleasure of being your host today, and I'm very much looking forward seeing you in the next one. So for now, take care and have a great week ahead. Bye bye. All right, so now I'll try to answer the questions that just came in. So there has been one quite interesting question. So 1 second, I just pull up the question. So if you want to have the slat position at 50% at 7 a.m., this is basically a time mechanism and not an automatic function. So this is basically just a time setting. I'm not sure if we can realize this with the ETS. I need to check it and I will give you the information. But what this would mean that you basically do not have an automatic function, so you only have a time function and is not controlled according to the external values. So as said, it would not be automated, it would be rather a time controlled functionality. Mr. Nuraldim, I will send you an email, or my colleague from the support team will send you an email about your requirements so we can discuss this in more detail and try to answer your question even better. Thank you for the question anyways.